Good morning, students. I am Samson, working as a physics faculty in Target English Medium School. Today, I would like to explain about the concept of pressure. What is the pressure and how the pressure is depend on the applied force and area of cross section with help of some suitable examples in the chapter of force. Okay. Now let me come to our topic directly in this time. So our concept name is our topic name is what is that one means pressure. So how to understand or how to define what is the pressure? Pressure is nothing but the force or thrust, the force acting per unit area. The force acting per unit area is called pressure. Listen very carefully. The force or thrust acting per unit area is called pressure. P is equals to F by A. Here, listen. Okay, this is the formula to find the pressure. P is the pressure, F is the applied force, and A is the area of the cross section. Okay. Now, we come to that one before going to some more explanation about the pressure. What are the units of pressure? So, units. Generally, the SI unit is SI unit is F is nothing but force, A is nothing but area. That's why the SI according to the formula, the unit of pressure is Newton per meter or Newton meter power minus 1. Next, but generally, so for the honor of the scientist James Prescott Watt, because he conducts some experiments about the pressure and gives some suitable examples too about this concept. That's why, Pascal. So that's why pressure SI unit instead of Newton per meter square, we are also called what is that one means Pascal. Okay. So this is we are write as a P of A. So listen very carefully. SI unit is Newton per meter or Newton meter power minus 1, or it is simply we are called what is that one Pascal. Okay. So 1 Newton per meter is equals to what is that one 1 Pascal. And what is the CGI unit? Force is nothing but dyne per what is that one centimeter. Here area is meter square. Okay, so force is measured in Newton, area is meter square. That's why Newton meter power minus 2. 1 Newton per meter square is nothing but 1 Pascal. In CGS unit, force is measured in dyne, area is in centimeter square. That's why dyne per centimeter square, that is the CGS unit of the pressure. Now we discussed how the pressure is depend on the force and area. So we know that P is equals to F by A. This is the main formula of the pressure. So from this formula, we are understanding the two concepts. First one is pressure is directly proportional to the F, means P is directly proportional to the applied force, and the second one is P is inversely proportional to the area. Okay, so from the main formula of pressure, okay, we are easily understand pressure is directly proportional to the applied force on the body, and pressure is inversely proportional to the area of the cross section. How they are depend on, that is we discussing that. Okay, with some examples, suitable examples. So here, listen very carefully. Okay. First of all, we can take a pen. Remove the cap from the pen. Okay. So in this pen, you are observing that two ends are there. At the lower end, blunt side is there, means flat like that one. At needing means not needing. Okay. So generally, at the another writing end, we are observing that a knob or it is a pointed end. Okay, means you are observing that in a pen after removing the cap, we are observing that at the lower end of the pen, means for example like this one. After removing the cap here, okay, it is a pen. In this pen, at the lower end, which is there, it is called blunt side or blunt end. And another one is a pointed refill. Okay, nib is there. This is the sharp end or pointed end. We are considered that. Now here we are observing that. Okay, so now what I will do here means the blunt end is placed on your finger at any one position. So means when a blunt side of the pen is placed on your finger, okay, so you are observing that the blunt side is occupies some space. Is it correct or not? Okay, so means the space occupied by an object when placed on it is called area of the cross section. Now here the blunt end, initially you are observing that here, okay, it is the surface of our, okay, what is that one? Finger. Okay, maybe now this blunt end I will place on the refill, and just okay, after placing this one, you are observing that this is totally covered certain part, means the pen is covered certain space on the finger. That is the, what is that one? Area. Means the area of the pen is occupied on the which one? Finger. Okay. Now come to that one. If after placing the blunt side on the finger, now okay, you are applied a little bit force. Okay. For example, for understanding of you, initially we are apply the 10 Newton force, just normally means little bit force. When you can apply the 10 Newton force, you don't feel any pain. Automatically we are observing that. But now in the second time, we are increasing the force. Means here you are observing that area of the cross section is does not change because of only blunt side placed on the finger. Initially we are apply the 10 Newton force. And second time we apply the 30 Newton force, means more pressure you can apply in downward direction. That's why when the pressure is increases, means at the 10 Newton force is applied on your finger through the pen blunt side, you don't feel any pain, but 30 Newton you feel a little bit pain is there. Okay, like the same way now we can come to the other side. The pointed end I placed on the finger. Okay, when compared to the blunt side, pointed end will be occupies very small area. Means now it is the finger I will be considered here. On the finger, okay, so this circle is represented the area occupied by which one? Blunt side. But the small point is represented the area occupied by the blunt side. So this is referenced as a finger. So on the finger we place a blunt side of the pen. This larger circle is represented the area occupied by the blunt side on the finger, and the pointed one is represented the pointed needle is occupy the area of the cross section. Okay, now here we are observing that okay, the blunt side is occupies the more area on the finger than which one blunt one. Means here what we are changing, area is changing. Okay, that is later we discuss that. Okay, so in the first case, okay, what you are observing that okay, the blunt side of the pen is placed on the finger. First we apply how much force, 10 Newton force, but you don't feel any pain. But after you apply the 13 Newton force, you feel a little bit pain. Okay, so why? Because area is constant. Okay, in the first case and second case, but what is different? Applying force is different. That's why if the force is increases, the pressure is also increases. Okay, if force will be decreases, pressure is also decreases. That is, we are observing that here. Means the pain is represented the pressure. Simply for understanding of you. Now we can come to that one. Pressure is inversely proportional to the area of cross section. Means same thing we have considered that. Okay. So for the second, for this one example, first one, what we can do means okay, same activity you can do. Okay, take a place the blunt end or blunt side of the pen on your finger and apply how much force? 10 Newton force. Okay, when you can apply the 10 Newton force, do you feel any pain? No, because of the blunt side will be occupies the more area, but due to that one, you don't feel the pain. Now the same in the pen. Now the okay, instead of the blunt side, we place the pointed end. After placing the pointed end, just you are applying little bit force only. Okay, you feel pain. Like the same way, 10 Newton force is applied. When you can apply the 10 Newton force on the pen, okay, through the pen on your finger, you are observing that you feel more pain than compared to the blunt side. So means what you are understanding here in the first case, by placing the blunt side on the finger, okay, you are applying the 10 Newton force, you don't feel any pain. Okay, but when the pointed end is placed on the finger and apply the same 10 Newton force, but you feel more pain. So means what is the constant here? 10 Newton means force is constant. Okay, force is constant, but what is not constant? Area. Blunt side occupies the more area. Okay, pointed end is occupies the lesser area. If area is more, okay, so less pressure is there. That's why you don't feel any pain. If area is less, okay, so pressure is more. That's why you feel more pain. That's why simply we can understand it with help of the pen and the finger concept. Okay, so pressure is directly proportional to the force. Means if the force is directly proportional to the pressure, anyone. If force is increases, pressure is also increases. Next in the second case, okay, area of the cross section is increasing, pressure is decreasing. Area of the cross section is decreased, pressure is increased. One more example I will explain about this one. Okay, what is that one means? Now we can take an iron nail. So we know that iron nail has two ends. So we are observing that it is an iron nail. Just you have considered that. Okay. So an iron nail has two ends. That is, you know that this is called blunt end and this is called sharp or pointed end. Now, okay, this iron nail we keep into the wall or we penetrate it into the wall. Just initially, what I am telling means the blunt side part. Okay, so means like in the pen. Okay, we have considered that. So this is the okay. Which one? blunt end of the iron nail, it is the sharp end of the iron nail, means lower. Now this blunt side of the iron nail we try to penetrate or keep into the wall. In this one, the blunt side is keep in contact with the wall, and we can apply some force with help of the hammer. You are observing that it is very difficult to penetrate this iron nail into the wall. Why? Because of means this is occupies the more area on the wall when we are placing that. That's why if area of the cross section is increases, pressure is less. That's why we apply the more force to penetrate it into that one. But now the pointed end or the sharp end is keep in contact with the wall and apply the little bit force only with help of the hammer. You are observing that immediately the iron nail is slowly penetrated into the wall. Means so what you are understanding that if area of the cross section is small, you apply the little bit force also, pressure is increases. Means simply area is less, pressure is more. That's why the iron nail can easily driven or penetrate into the wall. If area of the cross section of the iron nail is large or more, then pressure is less. That's why if it will be keep into the wall or driven into the wall, you are applying more force or pressure. That is one is it. Now come to that point. Based on this concept, regularly they are asking one question. Means during in examination. What is that one means? So two questions majorly they are asking that. What is the first one means? What about the pressure if force is constant? Listen very carefully. First one is what they are asking that F is equals to constant. That is asking that. Is pressure is increases when force is constant. Are you understanding my question? So the applying force is constant, but pressure is changes or not. That is he was asking that. But already we know that P is equals to what is our formula? Formula of pressure. P equals to force by area. Here force is constant means you don't consider this one. That's why for this concept, what you are considered that P is inversely proportional to area. Means P is equals to 1 by A. Means F is constant. That's why instead of the constant and equality symbol, I will write the directly proportionality symbol. Then P is directly proportional to 1 by A, or simply P is inversely proportional to the area of cross section. That's why. So now what you can do? The applying force on the object is constant. If area is increased, pressure is also increased. If area is decreased, pressure is also decreased. In simply, what you can understand in that when the applying force on the object is constant, but pressure is changes by changing the which one area of the cross section. I said in the iron nail or in a pen. So that's why in case of a pen concept, the blunt end is placed on the finger and apply the force 10 Newton. Do you feel any pain? No, because of pressure is less. But now the pointed end is placed on the finger and apply the 10 Newton. You feel more pain because of the applying force in the blunt side and the pointed side is 10 Newton only. But what you can changing by changing the area, pressure is also changes. That is the first thing. And the second thing is if A is equals to constant, means area is constant. If area is constant, pressure is increased or not. That is the one thing is there. Here now come to that one. If area is constant means this is the constant. So means force is not constant. That is the meaning of that. If force is constant means area is not constant, not same. That is the meaning. If area is constant means force is not same. That is the meaning of that question. That's why first one is if force is constant, pressure is changes by changing the area of cross section. And second one, if area is constant, then what about the pressure? Then P is directly proportional to the force. Now, in the same, okay, the blunt end of the refill or pen we place on the finger. Okay. Now it is first of all initially we are applied little bit force, maybe for example 10 Newton. You feel some pain, okay. But now in the second time you can increase the force, means 20 Newton. Then what happened in the second time? You feel more pain than the first one. Means when you are apply the 10 Newton force, you feel pain, means little bit pain. But when you can apply the 20 Newton, you feel, okay, so much pain. Here, little bit pain, listen very carefully. So, in case of pointed end concept, okay, area is constant, means when you apply the 10 Newton force on the pen, and 20 Newton force on the finger through the pen. So we place which one? Pointed end. That's why area of the cross section is constant. But when you can apply the 10 Newton force on your finger through the pointed end of the pen, so you feel little bit pain. But when you apply the 20 Newton, you feel so much pain. Means so if area is constant, okay, during such condition, by increasing the pressure or by changing the pressure, by changing the force, pressure is also changes. That is good. So once again listen very carefully. If force is constant, pressure is changes or not? Yes, pressure is changes when by changing the area of cross section. Next, second one is there. If area is constant, pressure is changes or not? Yes, pressure is changes when the applying force is changed, then automatically pressure is also changing. Like in case of iron nail also, okay, the sharp ended is keep in contact with the wall, and now we can apply a little bit force, maybe 10 Newton force on the blunt side. You are observing that it is a little bit going to inside, but now we can apply the more force, it will be go faster to that one. Means what you are understanding, by applying the little bit, okay, it is except a little bit pressure on the wall. By increasing the force, pressure is also increases on the wall, then it will be goes to inside due to yielding of the wall. That is, we know that, okay. And some examples we discussed about this one are applications. Okay, best one is one question is also asking about the pressure concept. What is that one means? Okay, why cutting tools have always sharp edges? What is the reason? This question they are asking for 1 mark, okay, in 8th standard level in the FA1, maybe in the formative or okay, summative assessment. Why cutting tools have always sharp edges? Best example is knife. We are considered that. Okay, everyone will be use the knife for different purposes in our home. Okay, most probably in case of vegetables and fruits, we consider this concept. Now I says that why cutting tools have always sharp edges? Sharp is nothing but, okay, you know that. If you can take a knife, okay, in a knife, the upper portion is blunt, means some flat is there, but the lower portion is very, okay, sharp is there. Okay, you are observing that. Now, if you can take any vegetable or fruit, okay, the blunt side of the knife is keep in contact with the vegetable and try to cut the fruit or vegetable. Is it possible? No. Why? Because of, if it is possible, maybe when you can apply the large force on the fruit or vegetable. Okay. But now in the second case, now the sharp ended of the knife is keep in contact with the fruit or vegetable. Just you can apply the little bit force. Okay, what will happen? It will be easily cut into the two parts. So means what you are understanding that. So So that's why the cutting tools, not only the knife, okay. So the crowbar, the sharp, the spade, okay. So hot saw blade, so many things are there. These all the cutting tools have always sharp edges. What is the reason? Okay, the cutting tools have always sharp edges because of to increase the pressure by applying a little bit force only. Means we put the little bit force or we put the little bit effort only for cutting the fruits or vegetables or whatever that may be. That's why what is the answer for this one means the cutting tools have always sharp edges because okay to increase the pressure by applying little bit force to cut the fruits or vegetables or any other thing with the cutting tools. Okay, that is one easier.